I'm going to use this opportunity to share we have GenAI semantic conventions and instrumentation working group in OpenTelemetry, which is the same as the project you've just seen, but in OpenTelemetry. Sorry. Okay. So this is the last talk of the day. You're exhausted, but let's have some fun. I'm here to share what we do in Azure SDKs, to deliver the awesome instrumentation that comes without dependencies, without plugins. It's just pure magic. So how do we do this? First, let me introduce myself. I'm Liudmila Molkova. I work at Microsoft on Azure SDKs. On observability, I'm the member of OpenTelemetry Technical Committee and maintainer of semantic conventions. Whew, sorry, I was running here. I forgot to take my bag from the bag room. Cool. So why do libraries need observability? Well, it's actually not for us. It's for our users, because we don't hate them, right? So it happens more that they want to, that user come to us with a question like, you know what, we're trying to upload some stuff to the blob storage. And it's slow, but only on Kubernetes. Why? And like, we have so many questions. What data, how much data, which region are you deployed to, where do you upload stuff to, do you see any errors, what are your Kubernetes limits, and the endless amount of questions, right? And there is a lot of keystrokes and unhappy users involved in this experience, also unhappy library developers, I can tell you. So we don't want this to happen. We want to provide observability to our users, so they can either answer these questions themselves, or when they come to us, they can answer our questions to them, right? Okay. So should we do more of this, the login stuff? Can you read it? Neither can I. So we prefer OTel, we prefer structured, queryable, unified telemetry. We want to have logs, we want to have metrics. We want to report them in a unified manner. But in order to do this, we need to actually depend on OpenTelemetry. And if you're a library developer, when you hear a dependency, no, just no. Straight ahead. So even a small dependency introduces a huge pain. There are like perception problems and there are real problems. With OpenTelemetry API, it's a tiny library. It's super stable. It does not have CVEs. It's not problematic. We are very serious about compatibility in OpenTelemetry world. But there are other libraries. And for example, my team owns maybe more than 100 of libraries in every language. So if we depend on something, and it has security vulnerability, and CVE is reported, we need to re-release everything with the updated version of the dependency. It's not fun. Nobody likes releasing libraries. It sucks. The other problem is the ecosystem problem. It's less of a problem in some environments, but let's say in Java, we have OpenTelemetry, we also have micrometer tracing, and some people don't want OpenTelemetry, or legacy applications. The other point is breaking changes. We definitely don't want libraries to introduce them, but they do. They do it in minor versions, patch versions. They do. And those are problems that are more perception problems. They don't apply to OpenTelemetry API. They do apply to other libraries. The key problem that still applies to OpenTelemetry, and you cannot fix it, it's the daemon dependency problem. It's also the forward compatibility. So let's say, let's talk about it more. Let's say my application depends on library A and library B. And library A wants OpenTelemetry API version 1.0. Library B wants 1.42. You would imagine dependency resolution mechanism would do the right job. No. Well, sometimes it's better. In Java, I think it's the worst. It's random. So if you use Maven, what it does, it explores your dependency graph. And the first time it discovers a library, it picks that version. So if you place library A higher than library B in your POM file, it will resolve 1.0. If you put library B higher, it would resolve 1.42. If you use environment like Spark, oh, God bless you, the Spark comes with a preset libraries that they use, and they ignore whatever you have in your POM file. They will just force something onto you. So in reality, what happens is, if you happen to use something like span set all attributes method, you expect it to be there. Your library depends on OpenTelemetry API that has it, but it was not there in 1.0. So you will get some runtime exceptions like no such method. So let's see a demo. I hope it works. Yay. OK, so here we have some application, some library. It's an uploader client. It depends on OpenTelemetry API directly. It has some instrumentation. In the POM file, you would see OpenTelemetry API. It is actually 142.1. And we have an application. Let's take a look at the application. OK, it depends on our library, but it also depends on OpenTelemetry SDK. And the version of this SDK, it should be actually 1.42. OK. And the application is super trivial. Let's take a look at it in a second. Here we go. So we just configure OpenTelemetry SDK. We upload stuff to the storage. Let's give it a run. OK, upload complete. Wonderful. So now let's go back to the POM file, and let's update the version to 151. We don't do anything bad. We just update the version of OpenTelemetry in application, right? It should be fine. Let's give it a run. Oops. So there is some OpenTelemetry API method that's missing in that version that SDK actually expected. So how do we investigate it? There is a tool called Maven dependency tree. There are other tools for other environments. My demo should get there in a second. We'll see it, I promise. OK, here we go. So it's very verbose, very detailed. It's somewhat hard to understand it, but you can see that there were the version 142 of OpenTelemetry API what was omitted. And oh no, it was actually used. And 151 was omitted because there is a conflict. And by having dependency on OpenTelemetry API version 142, we forced everybody who used this as library to get stuck on this version of API. OK, so how do we solve it, actually? There are a few patterns, common solutions. One of them is shading. It's also known as vendoring kin. So you take some external library, you bake it into yours if the license permits. You usually relocate classes, so there is no conflict. So it comes from like a different package. It works awesome for something like serialization or self-contained stuff. It does not work for observability, because you need the same type to represent the context, right? You cannot create a span as a child of something you don't recognize. Same goes to tracer providers and other things that SDK configures. So scratch this, shading doesn't work for us. The other common pattern is a plugin. You see it a lot, where the library itself never calls into OpenTelemetry directly. It has an abstraction. You call into abstraction. There is a plugin The plugin contains OpenTelemetry implementation. Plugin depends on OpenTelemetry API. Now, your users need to install this plugin first before they get observability. But once they do, does it solve any of the problems? Nope. It only solves the problem that it's very easy to roll back. If your instrumentation causes a problem, you uninstall plugin, you deploy your application, it's back to where it was. So it limits the blast radius, but it doesn't solve much. So the solution we are using, and we're very happy with it in our new generation of SDKs, is let's call it optional dependency for the lack of a better word. So essentially, we use the abstraction, the abstract span, or abstract metric, whatever. Everything calls into this abstraction. And at runtime, we see, oh, OK, is there a telemetry on the class path? Does user application depend on it? Is it configured? Let's use it then. If we see anything suspicious, if we see any reflexive exceptions and stuff like this, we can always fall back to a safer option. So this way, user just gets observability when they install our library. We don't force any specific version onto them. And also, we provide a nice fallback mechanism. So when things don't go as expected, if there is some missing API or something, we can still handle it gracefully. OK, so there are a few ways to do it. In Maven, it's called optional dependency. It still shows up on your POM file. We don't use it. In Gradle, there is a compile-only dependency, which is kind of awesome. And anywhere in Java and beyond, you can use a reflection for this. In languages like Python, TypeScript, you can always use duck typing of some sort too. But the principle is the same. So let's see a demo. OK, now we have a little bit more interesting uploader client. It also has instrumentation, but this instrumentation does not come from OpenTelemetry. It comes from the package called io.clientcore. It's the new core we have for Azure SDKs in Java. This library only depends on client core. We'll see in a second that it has no idea about OpenTelemetry, at least from the dependency tree. The application is pretty much the same. We have OpenTelemetry configuration, uploader client. We will run it in a sec, but first, yeah, in the POM file, we'll have the version 151 that we failed on before. And I promise we won't fail on it again, right? So we also depend on our new library. Let's explore the dependency tree. OK, so it's a little bit shorter now. First, you can see that the client core does not depend on anything. It's dependency-free. Yay. The only version of OpenTelemetry API we see is 151, which is awesome. It means there are no conflicts. And let's give this up a run and see what happens. So it succeeds. And we will see some traces in a sec. OK, this is the upload span we created in the library. There is also HTTP span under. Wonderful. So you might have questions and concerns. I did. First, it's error-prone, right? So imagine your code kind of assumes the OpenTelemetry is there, but it's not there in real life. So you need to be sure you always call into the abstraction. You don't call into OpenTelemetry directly. You should test without OpenTelemetry. You should also test separately with OpenTelemetry. And if you want to be robust, you kind of want to test with multiple versions, so you know what you're compatible with. You should probably prefer old and inconvenient APIs instead of bright and shiny new ones. And things sometimes will go unexpected, right? Like somebody will bring you OpenTelemetry 1.0 that you cannot be compatible with. So just fall back to whatever is your default no-op, or we'll talk about it in a sec. The perf, we're using reflection, we're using efficient reflection. But the perf, thanks to Jason talk, Jason is not here, but he talked about the percentage of overhead. Here, I don't want to talk about percentages. I want to say that our solution, which is not completely optimized, there is room for optimization. We have about 100 nanosecond overhead per span. Okay, so the last concern, the ecosystem, right? You kind of bake OpenTelemetry into your library. Guess what? You don't have to bake just OpenTelemetry. If you really want, we don't. You can bake micrometer tracing as well. But you can also fall back to something, and it does not have to be no-op. So my favorite part about it, that, okay, when user comes for support and they don't have OpenTelemetry, they do have logging, like chances are, some sort of logging. So let's leverage this. Let's degrade gracefully, right? So let's take a look at the demo. Let's take the application we just run, and let's remove OpenTelemetry from it. We'll comment out this code. We'll comment out all the dependencies. Let's pretend OpenTelemetry never existed. Okay, I'm just going to run this application. The first thing, it won't fail, which is awesome. The second thing, now you see a couple of log records that are written down. They are ugly, JSON, unreadable, but that's what logs are. They are ugly, unreadable JSON when you print them to console. Spans are even uglier when you print them to console. And they are actually spans. We are recording spans as logs. It's hard to read, but it's better than not recording them at all. And we even pretend to have tracing, not a distributed tracing. We generate the spans and the correlated, the best we can do. So yeah, that's essentially what I wanted to share. And dependency comes a lot. It's always a problem. And I wanted to find a solution, and I'm excited we found it. And I hope we can share all this ugly reflection code that we have with somebody else. If you are interested, there are links in the presentation. You can also chat with me, ping me on Slack, anywhere. And thank you for coming. It's the last talk. You're exhausted. Let's go have some fun.